Pixel art is an art form which has been around almost since the time we were able to draw images to the screen. This isn't to say we didn't have video games before pixel art, because we did. Remember Pong? Or, if you go even further back, Tennis for Two? They just shine some light on the screen, and you can't really consider that pixel art. If this was pixel art, a plain slice of bread would be gourmet cooking. We probably should really quickly talk about how pixel art works. I will gloss over things like memory limitations and how sprites work, because this essay isn't about that. Each sprite is made up of a grid of pixels, and each pixel in the grid has color information. I'll go more into detail later on, but you need a place to store that sprite. And to do that in the age of arcade games and cartridge games, you used something called a ROM chip, read-only memory. But the further back we go, the less data you could store on those chips. The first pixel art game, or at least to my knowledge, was Atari's second release after Pong, Space Race. Riveting, isn't it? Well, it was released in 1973, which meant that the capacity of ROM chips was minuscule, and furthermore, they were expensive. So, Atari had to knuckle down and come up with a different solution. Let's take a closer look at the shape of the ship. Bear in mind, this was during the age where having a controllable thing on the screen at all was revolutionary. See this spaceship shape on this arcade board? Doesn't it seem familiar? Yes, this is the board for Space Race, and this shape is actually how Space Race draws the rocket on the screen. It's an array of diodes that subtly manipulate the electricity going through the board, which is how this spaceship gets drawn onto the screen. It is, to my knowledge, one of the first examples of cheating in pixel art, or working within the limitations. One of the popular ways to cheat at pixel art back in the days of the NES was reusing sprites. Of course, you could just make a brick texture and make everything out of bricks, like in Namco's Battle City. But you could also get more creative, like in one of the most popular pieces of trivia in video game history. If you take a closer look at the bushes in Super Mario Bros. World 1-1, you can see that they shockingly resemble the clouds you can see above. Reusing of sprites slowly went away as developers got their hands on larger memory chips, but there was one thing they couldn't change: the NES color palette. The NES can only output a limited amount of colors, 16 to be exact, and they are always the same color. Additionally, each sprite can have at most 3 colors, plus the lack of color, which would mean transparency. There have been several ways to circumvent that limitation, however. For example, in Mega Man, you might notice that the Blue Bomber has 4 colors: blue, light blue, beige, white, and black. This goes way beyond the usual 3-color limit. What they actually did is they took advantage of a feature of sprites, the ability to draw them over other sprites. They first draw Mega Man's face, then they draw his body. The face has 3 colors: beige, black, and white, while the body has 3: black, blue, and light blue. Nowadays, the only reason you would limit yourself to the original NES's limitations would be for artistic expression, but another limitation of pixel art that is unrelated to hardware is time. Pixel art is very labor-intensive to draw. Modern tools improved the workflow a bit, but drawing pixel art is still more time-consuming than just making a 3D model. It also makes it much harder to animate, because you need to manually draw each and every frame of animation. Without putting in a massive amount of time, you end up with a very stilted animation. And putting a fully rendered 3D model in a static 2D pixel surrounding would be very jarring. So instead, the developers of Dead Cells decided to do something else.
I was actually using an advanced technique there called lying.
According to the game developer article by Dead Cells artist Thomas Vasseur, Thomas first models the character and its skeleton in 3D, which he then animates and exports in a FBX or Filmbox format. Then he takes the exported character and feeds it into a purpose-built program that renders the animations at a low frame rate, then scales the image down to a very small size. The rendered animations, alongside the normal map, which tells the engine how to render the light on the sprite, gets saved into a format that the Unity game engine can read and then gets played back in gameplay. Pixel art grew from being a style born out of limitation to an artistic statement, and the needs and abilities of developers grew alongside it. We can now do a lot of great things with this medium, and I'm anxious to see more games in that style.